I've been doing open source software for about 20 years now. And I've been at Google for the last 13 years. And amazingly enough, Google pays me to do open source software development full time. It's pretty much my dream job. Now, how did I get started? Like, why did I start writing software? And how did I get started in open source development? Well, I started as a systems administrator, and a really lazy systems administrator who wanted to automate everything ruthlessly. If I had to do something twice, I was going to write a script in it, whether it be Bash or Perl or Ruby, and then eventually Go. I ruthlessly automated, and that's what Google hired me to do. And it all started because when I was 12 years old, I used bulletin board systems. They're, kind of a pre-internet thing where you would dial someone's modem in someone else's house and you would chat with one another, share files. And I kind of fell in love with this idea of using technology to connect people from far away. And I knew by about age 13 that I wanted to be a systems administrator. I wanted to use technology to connect people. I was inspired by how useful these tools were and how easy they were to use. And I think all of you probably came into being software engineers similarly. You used a piece of software as a kid, maybe a little older, and you were inspired. You were like, this is so cool. I want to build cool stuff too. So that's a bit about me. Rewinding a little further, so yeah, there's a wonderful picture of me in 4th grade. So I was actually born in Sweden. Swedish was my first language, but I moved to America at a young age. And learning English was very painful. There were so many misunderstandings. I had to learn English when I was 5, and I learned from a lot of bad 1980s movies, like Police Academy and Fletch, and really bad movies, and I had a very bad vocabulary as a 5-year-old in school, and it caused a lot of problems. And it helped set me on this path of realizing that almost all conflicts and problems that people have are simple misunderstandings. A lot of cultural misunderstandings, language misunderstandings, we're full of it. And so when I had kids of my own, I highly encouraged them to go to a language immersion school so that I can inflict that same pain of complete misunderstanding and that growth model of always feeling like you have no idea what's going on in the world, but you have to struggle through it anyways. Now, I asked my oldest, I live in San Francisco, there's a lot of different languages you can choose from. They chose Cantonese. Why did she choose Cantonese? Because she likes dumplings. So that's Chun Tin Sing, and I am Chun Tomasi. But anyways, so in thinking about this talk, I was really thinking a lot about the role of a programmer. And how many of you here have read The Mythical Man Month? It's one of my favorite books about programming. Yes, it's old. I mean, a lot of it takes place about like describing what happened in the 1960s and 70s. And what you realize when you read this book is that we haven't solved very many of the problems that he talked about. And one of my favorite quotes from it is that the programmer's role is to deliver satisfaction of a user need rather than any tangible product. And when I've managed other software engineers who complain about, oh, I hate when they change the requirements, and why do I have to talk to users, and why do I have to deal with people? As a software engineer, your role is delivering satisfaction. It's not the code. It's the satisfaction. It's meeting a need. And so my own interpretation of this is that successful software adapts to the needs of users, and successful adaptation requires empathy. Now, empathy in terms of my talk is understanding the needs of the rest of the world. I live in San Francisco, I have great internet access, I speak English. Kubernetes is pretty easy for me compared to most of the world, I feel. So, some tools to gather empathy that I recommend is surveys. actually asking your users, what do you want? And some sort of like free-form way, performing user journeys where you actually sit there and watch a user try to use your tool, a user who's never used your tool, who is not aware of it, and say, use this, and then you write down every step that they took and every bug that they surfaced, because they will surface a lot, even if your software is really good. If it's your first user journey, it will be painful. The first time I did a user journey for Minikube, and I wrote down all the steps a Windows user had to take to run Minikube, I wanted to cry. I think it was 63 steps to a working cluster, and it was just like, this is not the way the tool is supposed to work. And then GitHub issues, of course, reading through all of your issues and trying to discuss with the people on what they're saying. One of the problems with all these approaches, though, is what if, like me, when I was learning English, I was embarrassed to speak. And then eventually when I moved back to Sweden, I was embarrassed to speak Swedish because I'd forgotten so much Swedish. What if, like me, you are too embarrassed to speak? You lose. The people who are too embarrassed to speak do not answer surveys, do not participate in user journeys. They don't open GitHub issues. And we see this a lot for people whose native language is not the native language of that project. So you have a lot of work to do on that part, and that's where I wanted to discuss the next billion. So who am I calling the next billion users in this case? And it's 43% of the world that did not use the internet last year. That's a huge untapped market for not only users of your project, but members of Kubernetes, future software engineers. There's a whole, nearly half of the world out there that doesn't yet know what this is all about, why we're meeting here today. The next billion users, it's unlikely they're going to speak English. I mean, it's roughly 20, it depends on like how much English they speak, but most statistics put it around 20% that speak English. So that's 80% that do not have a working English vocabulary. The next billion users probably they don't have gigabit Ethernet. It'd be nice. The average speed, though, is surprisingly good. I was expecting like maybe megabit, 2 megabit. The actual global average right now, at least according to the stats I found, was closer to 9 megabit, which is not too bad. But when I look at it in terms of how long is it going to take to install, like to actually download all the images for Minikube, your average user in Egypt is going to wait about an hour to download the images. And if you're wanting to teach Minikube, they're like, I want to learn Kubernetes. I'm going to install Minikube, and then it's like, okay, now wait an hour. And are they going to be interested after that? I don't know. The first time I downloaded Minikube and tried to use it, I don't know if I was that interested. So, the next billion users are not Linux experts. Well, at least not yet. If you look at operating system statistics, you'll see like China, for instance, is a great case where the desktop share for Windows is, depending on the stats, about 90%, which is actually much more than the United States. The share of Mac users in China is much lower than in the United States, which is a shame because, like in Minikube's case, our best working platform is Mac OS. But most of the world does not run Mac OS. So a substantial portion of this next generation will be inspired to become programmers like us. And we really have to be good stewards and help them with that effort. It's a great equalizer. So how do we adapt Kubernetes to make it applicable to these next billion users? Well, empathy and accessibility. And so empathy by reaching out and trying to get their inputs, and accessibility by actually like taking those inputs and making Kubernetes work for them. So I would argue you should not have to learn English to use the internet, and you should not have to learn English to use Kubernetes. I think that's one of my big points. if we fail to make Kubernetes accessible globally, we'll end up with splintered solutions for managing compute resources. Can you imagine if Kubernetes actually came out and was the same product it is today, but was only available in Icelandic? It probably wouldn't be that popular, but we could easily see a world that if we didn't try to make things globally applicable, that Iceland could have its own Kubernetes that almost nobody uses because it's a tiny country, and that China could have its own Kubernetes and the US could have its own. I saw this in the 1990s with Unix. Back then, every different hardware manufacturer had their own Unix flavor. STI had IRIX, IBM had AIX, there's HPUX, DEC Ultrix, NextStep. If you wanted to change, if you wanted a feature that was available on a Unix system that your machine couldn't run, you would have to buy a new machine. And then Linux and the BSDs, they all came around, and it completely changed the environment. And there are, with the exception of Mac OS, they're all effectively dead, thankfully. So what I would like to ask you to consider is to be part of this virtuous cycle. If you want to make the most of your investment in Kubernetes, you have to share with the community, and because you have a really special, unique viewpoint and circumstances, and even if it feels uncomfortable to share, it's going to make Kubernetes a better product. So, back to Minikube for a moment. How many people in this room have not used Minikube? All right, then okay, there's a handful of you. So Minikube is like I liken it to a computer game like Kerbal Space Program, where you want to do a simulation of a production environment, and you want to do it locally. It's a SIG cluster lifecycle project. You can just do Minikube start, and you get a working Kubernetes cluster locally, or you can go into the options screen and tune all sorts of things. And so it's great for developers in that case, but when we've done surveys, we've seen that about 30% of Minikube users are installing it just to learn Kubernetes. They're not developers yet. They want to see what it's all about. And I was one of those people when when I saw an opportunity to join a Kubernetes group, I was like, let me learn Kubernetes. Minikube looks easy. And then I got really sad. So I'm going to give a little demo here to kind of demonstrate some of the things we've been doing lately. And we'll just leave it up. Why don't we just set some memory? So one of the things you might notice that we've done lately is we've done language localization. The translations might look a little strange. We currently have one issue in that our string interpolation currently has to be in the same order as English. So when you say like Kubernetes 14 on Docker, when we translate to another language, we also have to have the same order. We have to move to a more flexible format where we're actually using like named variables everywhere. And so that will come very soon. So in fact, we actually have this turned off by default in the current release until we get that issue solved. But you can basically see here two of the features that we've done recently, which is, we're starting Minikube. We've selected an image repository that works in China. We selected here, image mirror country, China. There are still quirks with Chinese access because we still have to download the ISO file from Google, and it will switch to GitHub very, very soon. These are the kinds of experiences that I learn when I come and visit China for the first time. I apologize for all the pain that we have inflicted on you. So, but anyways, in a moment, we will end up with a working Kubernetes cluster. And while that's going, I will go on to another slide. So what Minikube aims to deliver are all the Kubernetes features that actually fit on a single machine. It actually turns out this is pretty much everything. You can run into memory restrictions if you run out of memory. Istio users tend to run out of memory because Istio may need more memory than you have on a single node. But so how Minikube works is we have a machine driver, in this case VirtualBox, that basically starts the ignition sequence. It starts a Minikube VM, Minikube ISO. We have a bootstrapper. In this case, it's always kubeatom. You get to select your container runtime, like Cryo or Containerd, gvisor, your Kubernetes version, whatever add-ons you want, like Ingress, and then your application at the end. So we have a kind of ridiculous support matrix. So the Kubernetes official policy is that Kubernetes only supports the last 3 versions. We recognize that there are a lot of legacy users out there, so we test the last 6 versions currently. We will always guarantee the last 3 versions, but we will try to do 6 if it's viable. We support many runtimes. Kata we don't support yet. There are plans for 2019. Intel has been working on some contributions there. For bootstrappers, we only do kubeadm right now, but we are also prototyping with Kinder. We have a bunch of VM drivers that we support. We would like to do Docker and Podman as VM-free drivers soon. Operating systems are as expected. I hope that continuous testing will be re-enabled on Windows next week. And as far as architectures, most users are on 64-bit x86 64, though there are people who are using Minikube on ARM64 and even S390X for IBM mainframes. So one of the things that I've really thought about, because my first start with Minikube was really tough, was thinking about causes of friction. And it really made me think back to being a child and learning a new language, which was that, as with all things human, most software friction is due to a series of simple misunderstandings. Some of the misunderstandings are from a user to a developer, but some of the misunderstandings are from a developer to a user, not understanding the use cases of their users. I find the latter to be the most frustrating, I think, because it shows a lack of trying in a way. So here I have my local Kubernetes up and running, and kubectl is also localized already. So probably nothing I really need to show there, so for Minikube, you can start the dashboard. But one thing I wanted to show that was kind of a recent feature is Minikube recently added this tunnel node. And I recognize that the font size is really tiny. The Minikube tunnel, what it does is it's primarily used for people using load balancer types within Kubernetes. It will make your load balancers appear local, and it'll also, actually I'll just do this. Okay. One of the things that we've recently added for Mac users, although, oh, sorry about that. So one of the fun things is that you'll notice, at least on Mac, is that DNS resolution from Mac works directly into your Kubernetes cluster if the tunnel is running. So if you are dealing with load balancer type apps, this is a really handy way to do local development. We would love to get this feature added on other platforms, and help is certainly welcome there. This was just a random contribution from an end user to do it for Mac. So, all right. So the strategy for Minikube, as far as trying to solve these misunderstandings and really adapt it to the next billion users, is to meet users where they are, whether it be language, environment, documentation, or a skill level. we're kind of attacking on all fronts there. Now, when I first proposed to give this talk in April, I was sure that I was going to solve all these problems by the time June rolled around, and this was going to be my big success story. It turns out that the world is complicated, and this is very much a work in progress. So language, I did show the localized command lines. We are also working on localized documentation and localized feedback. And what does localized feedback even mean? I will show you, for instance, if I can. This is relying on the network. So we've recently made an effort here when you open a new issue, that when you open new issues now in GitHub, you can open issues in different languages. And this is one of the ways we're trying to attack that. What we found is that most people in the world that use Kubernetes, like we see all these downloads from different places, we're not actually getting very many bug reports. We, for a while, didn't get very many bug reports from China, so I actually didn't know how bad things were. And I think part of this is people will always feel uncomfortable sharing feedback in a language other than their native tongue. So we're trying to do this and kind of bear the burden of the translation with the help of the community and trying to understand what these issues are. We want everybody to feel comfortable sharing their inputs. If I can find my slide. And yes, we definitely need help on language. It's certainly a community effort. Oops. We'll see. So digging a little deeper into how our translation works. One of the interesting, so it turns out that language translation in Go is not as straightforward as with other languages. The libraries are not as wonderful quite yet as, say, Java or C++. If you want to, say, for instance, extract all the strings that need localization, there are some pretty hacky ways. We chose to go for an AST-based approach, where we actually use Go's AST parser to parse all the parse Minikube and grab all the messages that we send to the output library. It turns out this is both fun, fascinating, and scary, the way that how much work actually has to go into this. We really want to make this a general library in the future. But what do we do with all the extracted strings? Well, we dump them to a JSON file, and here you can actually see the issue I was talking about, where we're still using string substitution in this initial prototype rather than named variables. But it turns out this format is pretty easy for people to work with, at least. And then we load this in at start time. Another part of localization is not just language. There's, as I'm finding out, especially in China, networking environment is huge. So one of the things that we added earlier was Minikube runs offline, and it has since 1.0. You can copy this directory if you want to have Minikube running on a different machine than you already have access to. We did get the image mirror country. We'd like to make it automatic, though. Right now, we don't have a way of validating the contents of images from other mirrors. We have ideas on how to do this by basically pinning to hashes, but we definitely need help there. As I mentioned earlier, we need to move the release ISO to GitHub. We've done a lot of work recently to improve proxy support. It turns out that some of the more popular user support issues are people who have their machine set up to use a proxy, and then when we try to access the API server, it's going through the proxy. So now we ignore the proxy configs for VM communication. System environment is also important. As I mentioned, operating systems are different between countries. We would like to make Windows a first-class operating system when it comes to Minikube. That's going to mean me and others switching our development workstations to Windows for a while, and ferreting out the bugs, and of course getting help. We want to make, like Windows right now in VirtualBox is okay, but Windows on Hyper-V, there's a lot of problems primarily with stopping the VMs. We would like to make that and WSL2 first-class solutions for Minikube. Part of the WSL2 approach is we want to make VM-free better. I have this goal of Minikube start, at least after the first start, only taking 15 seconds. We are far away from that right now. And part of doing that is we'd like to do direct deployments to Docker and Podman. Very similar to Kind, and in fact, that's what we're using to prototype. We're hoping to build this on top of the Kinder library, and we'll be working with the Kind folks on doing that. So Kind is very focused on fast conformance testing, and they're laser focused on that. There's a lot of features that Minikube has that they don't. For instance, the switching your runtimes, flag-based configuration of API server and kubelet and things like that. And so we want to build those types of features on top of it. But we still are not abandoning the VM-based methodologies because there are still really good cases for VMs. Great documentation drives adoption, and so we're taking documentation very seriously. We do have a Hugo-based website that we have just started rolling out. It doesn't have very much at the moment because I am still learning on how to do menus in Hugo. If there are any Hugo experts out there, I would love your help. So yeah, there's definitely help wanted on the documentation. I would like to get all the documentation translated into, into the same languages that the rest of the Kubernetes docs have. And we could definitely use tech writers to review PRs for documentation to help let us know where we're falling flat. And how we approach skill levels, well, because Minikube is a learning tool for a lot of people in the world, we want to make sure that the errors are very actionable. It used to be, like when I first started learning Minikube, that I would get a panic or a backtrace or some inscrutable message. I didn't necessarily know at the time what the different hypervisors were. So now we've made it for many errors, we actually point users to a specific document to read or a GitHub issue to read. So we basically have this file that is a set of regular expressions to say if the error message looks roughly like this, give the user this advice. And that's actually worked really well for lowering the amount of duplicate issues that we get in Minikube and lowering the number of issues that we have altogether. One of the things we'd also like to do is a single-step install. Right now with Minikube, chances are you also have to install a hypervisor, maybe a machine driver. Users should not have to learn about machine drivers or VMs to use Kubernetes. Why should we make them know that for Minikube? The more, in my experience with automation, the less you involve users, the less you involve like human toil, the less your support cost. And while I love talking to people, I really hate going through the same GitHub issues every day. So I would like a single step installer that basically just fixes everything for you. And similarly, no flags required. I would like it so that when you run Minikube on a machine, if you have HyperKit installed and you don't have VirtualBox installed, it should just default to using HyperKit instead of making you set something specific. It should just start with no flags, no matter the environment. So a couple other 2019 roadmap items, multi-node, reducing guest VM overhead, and moving to PROW. We actually have a public roadmap here for 2019. So unsolicited advice, overcome your embarrassment. Badly translated inputs are better than no inputs. Even if you have to run your thing through a translator to open a GitHub issue, just do it. We want to know what's going on. Project owners have it in their best interest to have your help. Projects, the project with the most inclusive community wins. We've seen this with Linux, we've seen this with Kubernetes. Onboarding is as important as coding. Ignore the next billing at your peril. So if you're interested in joining us, there's a couple of things here. The survey is embarrassingly not available in China without a VPN. You can see that our survey is not as useful as it should be. I will work on fixing that. But yeah, non-English speakers, welcome. Feel free to contact me on WeChat or Twitter. So any last questions, or any questions, I guess? Oh, here. Let me.
If I set the image mirror, language thing,
Yeah.
I can get the image, Kubernetes image in China.
Yes. Yeah. If you set it to CN.
Second.
Yes.
If I second minute is the Minikube
Yeah, it's working. It's working.
我用中文行吗？
If you understand Chinese.
No.
不用，我不用。
必须要翻译，我们要翻译，
OK，这个 Minikube 和这个 Kind and 那个 Kubernetes 的区别是什么？
Minikube and KubeAtom? So Minikube uses KubeAtom underneath. So KubeAtom is great for running a local Kubernetes on your host, whereas Minikube runs it inside of a VM so that you can destroy it and recreate it. KubeAtom could have, if you run KubeAtom on your machine, you could open it up to issues where you might actually like delete files or delete stuff in Docker. Whereas when you're running it inside of VM, it is constrained to that environment. And it's important primarily for running on macOS or Windows. So if you run Minikube with the none driver, it actually just uses KubeAtom underneath on Linux. If you run it with any of the drivers, but it's effectively KubeAtom. All right. Any other? Yes. Yeah.
When will it release?
So it's on our roadmap for 2019 to be developed, but it'll probably be at the end of the year. If you are interested, we could really use the help on that. Somebody's made a prototype in the past. We don't have anyone actively working on it that I know of, so I would love to hear from you. All right. Thank you. I'll be outside here if you have any other questions. Thank you.